Hello, we're going to go over Statistics, Chapter 2, Section 2.2. So we've made a dot plot, histogram, and a standard leaf plot. Now we're going to analyze them a bit. So a couple of things we can do is look at the overall pattern of a distribution. So for example, we can look at a center. Now center could be the mean, the median. We'll get into that a little bit later, but if I go back to the dot plot, at the dot plot, there are 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. There are 24 numbers. So the center would be about the 12th one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 6 would be the center. So the center for the dot plot would be 6. Now if we go to the stem plot, we'll go to the regular stem plot. Again, there are 24 numbers, so the center would be about the 12th one. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 19 would be the center of the stem plot. We can also look at the spread. The spread is from the lowest to the highest. So the spread for the dot plot would be from 5 hours to 10 hours. The spread for the regular stem plot would be from 0 to 100. So spread from the lowest to the highest. Then we can see if there's any outliers. So if we look at the dot plot, now there's a formal definition of outlier, but for us we're just kind of looking at it. So if I look at the dot plot, it looks like all the data flows, there's no breaks or gaps, so I'd say there's no outlier. Then we can look at the regular stem plot. Notice the data flows, 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 flows. Ooh, there's a large gap here. So we can consider 100 an outlier. It's outside the rest of the data. We can also look at the shape. So notice if we kind of throw a blanket over our data, what shape would it be? And there's 3 basic shapes. Symmetric, which means the majority is in the center. Skewed to the right, skewed to the left. Now people confuse these a bit. So skewed to the right doesn't mean where the hump is. It means where is the drag or the pull. So here the drag or the pull is on the right, so this would be skewed to the right. Skewed to the left would be the drag or the pull is on the left side. So if I go look at my dot plot and kind of throw a blanket over it, we would say that through a blanket, and then notice that there's drag on the right. So the majority is on the left, the drag is on the right. This can be considered skewed to the right. And if we look at the regular stem plot, and again we kind of turn our heads this way, notice the majority is on the left with the drag on the right. This would also be skewed to the right. Skewed to the right. Majority in the lower end, few on the higher end. Okay? We can also look at mounds. Mounds would be how many humps there are. So for example, if it's 1 hump, we call that unimodal. If there are 2 humps, we call that bimodal. Anything beyond 2 we call multimodal. So an example of this would be the majority is in the center. Most people fall in the middle. Here, maybe there's 2 places where the majority falls. So for example, when do you like to work out? Well, many people work out in the morning. Many people work out in the evening, but not many people work out in the middle of the day. So that could be an example of bimodal. And then we can also look at variability. Variability would be how spread out the data is. So if you look at these 2 pictures, notice that they're both symmetric. They're both unimodal. So they would be exactly the same, except for this one's more spread out than this one. This one goes from about 0 to 32. This one kind of goes from 8 to 24. So the top one has more variability, where the bottom one has a lower variability. Instead of going from 0 to 32, it only goes from 8 to 24. So when we look at data, we can talk about the center, the spread, the shape, and anything unusual. So I asked my class, how many hours a week do you work? So I have this data, 33, 0, 0, 36, 20, 28, 18, 30, 0, 25, 0, 0, 0, 0, 61, 30, 38, 55, 36, 28, 24, 0, and 29. So we want to analyze the data. So one thing we can do is we can make a regular stem plot. So lowest is 0, highest is 61. So notice I went from 0 to 6, 0, 1, 2, 3, 4, 5, 6 on the left. Drew a line vertically after that. Those are my stem, and then my leaves would be on the right side. So I would put 0. In the zeros row, anything that starts with 0, so it would be 0, 0, 0, 0, 0, 0, 0, 0, and there's 1, 2, 3, 4, 5, 6, 7, 8 zeros, and then the 8 would also go in the zeros row. In the ones row, we'd put the 8 to represent 18. In the twos row, we'd put 0, 0, 4, 5, 8, 9, which would be in the 20s. 3, the 30s row would be 0, 0, 3, 6, 6, 8. Nothing in the 4s. There's nobody who works 40 hours or in the 40s. We have a 55, represented by a 5, 5, and a 61, 6, 1. That would be a regular stem plot. And then we can also make a histogram. So we're going to go back to our calculator. And this time we're going to use not list 1, but list 2. So I'm going to go to my calculator, turn it on, stat, number 1 for edit. And I'm going to use list 2. So I'm going to put those numbers in, 33, 0, enter, 0, enter, 36, enter, 20, enter, 20, enter, 8, enter, 18, enter, 30, enter, 0, enter, 25, enter, 0, enter, 0, enter, 0, enter, 0, enter, 61, enter, 30, enter, 38, enter, 55, enter, 36, enter, 28, enter, 24, enter, 0, enter, 29, enter. And there's 24 numbers, double, triple check of all of our data. And to make a histogram, we go to second, y equals for stat plot. Notice we used plot 1 already, and it's still on from the last video, last example. So we're going to stay in plot 1. So I'm going to hit enter. I'm only doing one plot, so I use plot 1. Keep it on. I still want a histogram, but I'm going to change it to list 2 this time. So second 2, move it up, up, up. Remember, hit zoom 9, it makes its own window. And there is our histogram. Now if you look at this, it's a little different than what I've drawn here. Notice that it's different than what I've drawn here, and you're like, what happened? But again, we need to double, triple check our data. If you had noticed along the way, when I hit stat, edit, there wasn't a 208. So if I go back and check, we have 33, 0, 0, 36, 20, 208 should just be 20. So double, triple check your data. If one number is wrong, the whole thing's wrong. So notice it's 20, 20. Then we have 18, 30, so we're missing an 8. So we can insert here, second, delete for insert, 8, enter. So we double check our data. So from the top, we have 33, 0, 0, 36, 20, 28, 18, 30, 0, 25, 0, 0, 0, 0, 61, 30, 38, 55, 36, 28, 24, 0, 29. So double, triple check your data. 24 numbers. Now when I hit zoom 9, it matches. So I can hit trace, and again we can label it 0 to 10.2. There are 8, 10.2 to 20.3. There are 3, 20.3 to 30.5. There are 6, 30.5 to 40.7. There are 4. Notice there's a gap there. 50.8 to 61. And then we can kind of analyze the data a bit. So if I look at this data, we can say that it's skewed to the right. The center is about the 20th one. It has 24 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 20 would be the center, because there's 24 numbers. The center would be about the 12th one. You could argue that it's bimodal. There's 2 humps in here. Someone might argue that it's only 1, but again, it depends how you can see it, and that's statistics. It's how you see it, how you can back it up. So I'm going to say bimodal, and again, in this example, talk about how many hours a week you work. It looks like these students work either no or very few hours, or part-time. Notice we don't have many full-time, because most of these were all students, so they're in school. The outliers can be considered 55 and 61. So if you're in school full-time, let's say, that you're not able to work over full-time, That'd be a little unusual, and the spread would be 60 to 61. Thank you.